Hello, my name is Jared Skeens and welcome to Quick Fix. Today we want to look at IGCSE May-June Series 2019 Paper 22. It's an hour and 30 minutes long. I've already worked it out for us. Again, focus on how to set up the questions, focus on the thinking through the question, not just on the number at the end. So here we go. Number one, write down a prime number between 50 and 60. Remember, a prime number is a number where only one and itself divide into it. So only one and itself divides into it. Obviously, all the even numbers are divisible by 2, so it can't be an even number between 50 and 60. And so here we see 53 or 59, either one of those are prime numbers. Number 2, use your calculator to work out this problem. Notice it's a trig function in degrees, so make sure your calculator is set to the degree mode. And you have the square root, which goes over the whole thing. And then on the inside, 1 minus sine 33 degrees squared. So make sure that you're careful how you enter that into your calculator, and you should get 0.839 to 3 significant figures. Number 3, we have a reoccurring decimal again. So here we have 0.7, and there's a dot over the 7, meaning the 7 repeats. There's only one digit that repeats, so we start off by writing x equals 0.77. You can put the 0.77 if you want. And so we showed one repetition of the number 7. You can show more, but you really only need one more. And since only one digit repeats, we're going to multiply both sides by 10. So remember, if one digit repeats, multiply by 10. If 2 digits repeat, multiply by 100. If 3 digits repeat, multiply by 1,000. So this is one digit, so we multiply both sides by 10. We get 10x equals 7.77. We subtract. That gives us 9x equals 7, because all of these repeating 7s then cancel out. Divide by 9, so x equals 7/9. Number 4, complete each statement. A quadrilateral with only one pair of parallel sides is called. And remember, this is Cambridge, so this is British English. They call it trapezium. So if you happen to be used to American English calls it a trapezoid. So a trapezium and a trapezoid in the British English and the English or American English are actually flip-flopped. So this is a trapezium in the British English, but if you're used to American English, it would be a trapezoid. Letter B, an angle greater than 90 but less than 180 is called obtuse. Number 5 says the distance between Prague and Vienna is 254 kilometers. The local time in Prague is the same as the local time in Vienna. A train leaves Prague at 15:20 and arrives in Vienna at 19:50 the same day. So from 15:20 to 19:50, that's 4 hours and 30 minutes. Calculate the average speed of the train. Remember, average speed is total distance divided by total time. So the total distance is 254. The time is 4 hours and 30 minutes, which is 4.5 hours or 4.5. And when you divide that, you get 56.4 kilometers per hour. Now we have this solve the equation. 9f plus 11 equals 3f plus 23. So we want to solve for the f, subtract 3f to both sides, and we get 6f plus 11 equals 23. Subtract the 11, 6f equals 12, divide by 6f equals 2. That's pretty simple algebra there. Then we get this triangle, calculate the area of a triangle. So the geometric formula is 1/2 base times height, And since we see a nice base and height already, then that's the formula we'll use. 1/2 8.4 times 3.5 is 14.7. Then number 8a, write 0.047883 correct to two significant figures. Now remember, zeros on the left are never significant. Zeros in between non-zero digits are always significant, and zeros to the right are significant only if a decimal is expressed. So here we have zeros on the left. Those are not significant. So to go to two significant figures would be the 4 and the 7. But after the 7 is an 8. So that's going to round it up to 0.048 is our two significant figures. Letter B, write 0.00527 in standard form, meaning scientific notation. As mentioned in a previous video, you can set your calculator into scientific notation mode, or you can just do it manually. Since there's only one number here and we're not calculating anything, we'll just go ahead and do it manually this time. But you can look at a previous video to find a standard form where we set your calculator to the scientific notation mode. So on the rule that you need to remember is you're only allowed one digit in front of the decimal. So the decimal is right here in amongst the zeros. So we need to move it 1, 2, 3 spaces to the right. So we only want the 5 to be in front of the decimal place, only one digit in front of the decimal. So we got to move it to behind the 5. So that's going to be 5.27. And notice we've made the number bigger. That is, it was 0.005 and now it's 5. So it got bigger, which means our exponent needs to become negative. Okay, so in other words, we want this decimal that's 5.27, we want it to go to the left in the negative direction in order to get back to our original number. If your exponent is positive, it would mean your decimal would move to the right. We don't want it to move to the right. We want it to move to the left when we go back to the original number. So 5.27 times 10 to the negative 3. Number 9, find the highest common factor, or some people call it GCF, greatest common factor, of 90 and 48. So what you want to do is you want to do a factor tree for both of your numbers. So here's 90, 2 times 45, 5 times 9, 3 times 3. A factor tree is just keep dividing it until it's all prime numbers. So here's our 48, 2 times 24, 2 times 12, 2 times 6, 2 times 3. So the outside list of numbers are the prime numbers. Then you look at what is common to both. So there's a 2 common and there is a 3 common. And when you multiply those together, you get 6. So 6 is the greatest common factor that 48 and 90 have together. Moving on, we have another map with the scale. So the scale or the ratio is 1 to 25,000. 1 centimeter of map represents 25,000 centimeters of actual length. And it says that the area of the lake, and notice we're still dealing with on the map, the area of the lake is 33.6 square centimeters. Obviously, that should not be the area of the actual lake. That would be more like a little mud puddle. So calculate the actual area of the lake, giving your answer in square kilometers. So we're going to start with the ratio. Again, there's 3 things that you want to pay attention to. 1 is the ratio. 2 is the dimension, that is linear area or volume. And the third thing is the units that you need to be in. So we'll start with the ratio 1 to 25,000, and we need to get it from linear ratio into square centimeters, which is area. So to go from linear to area, we need to square the ratio, and that gives us 1 over 625 million square centimeters. And then we want to take that and set up a proportion with what is given here. The 33.6 would be the scale on the map size, and then X is the unknown actual area of the lake. So the map versus actual from the scale, and then the map versus actual for the lake. Cross multiply and solve for X, and we get X equals 2.1 times 10 to the 10th power. So when you take 33.6 times 625 million, it's obviously a large number. It changes it to scientific notation, 2.1 times 10 to the 10, and it's in centimeters squared. We need to change it to square kilometers. So here's our first conversion factor here. We want to get rid of centimeters, so we put 100 centimeters on the bottom, 1 meter on top. We're going to square it because, again, we need to be in area. And then we have 1 meter, and we want to go to kilometers. So 1,000 meters on the bottom to make the meters cancel is 1 kilometer on top. Again, we need to square it so that it's area. And when you multiply all this through, the 2.1 times 10 to the 10th times 1 times 1, of course there's 1 squared times 1 squared, divided by 100 squared and 1,000 squared. Don't forget to square the 100 and the 1,000 in the denominator, and you end up with 2.1 kilometers squared is the size of the actual lake, 2.1. Okay, moving on, number 11, write down the matrix that represents an enlargement, scale factor 3 with center 0, 0. So actually for the new 2020 syllabus cycle, you don't have to do matrices anymore. And again, I've already made my comment on that. I kind of wish they would continue matrices because it's used with vector fields in higher mathematics. But nonetheless, technically, you don't have to do this, but in case you're interested, when you're dealing with scale factor and enlargement, the matrix follows your identity matrix where it's 1, 0, 0, 1, and all you do is you just multiply the scale factor into where those ones are at. So since these are usually ones and the scale factor is 3, it's now 3, 0, 0, 3. So those are actually quite easy to do, but you shouldn't see that in the new syllabus cycle. Number 12, we have some exponential rules. 5m squared times 2m cubed. Remember, when you multiply the basic math part, that is the coefficient, sign and coefficient. 5 times 2 is 10. And then for the variable and exponent part, that's your exponent rule. When you multiply like bases, you add exponents. So 2 plus 3 gives you m to the 5th power. So 10 m to the 5th power. Then down here we have an exponent raised to an exponent. When you have an exponent raised to another exponent, you multiply. So you get x raised to the 8 times 3, which is x raised to the 24th power. Number 13, without using a calculator, work out 2 1/4 divided by 3/7. So here I wrote it down here, 2 1/4 divided by 3/7. So change our mixed number into an improper fraction. 2 times 4 plus 1 is 9 over 4. And then I changed the division sign into a horizontal bar and put the 3/7 down in the denominator. So this creates a complex fraction. And when you divide by a fraction, you invert and multiply. So we're going to multiply by 7/3. And the 3 and the 9 cancel, giving us a 3 on top. 3 times 7 is 21. And all we have left on the bottom is the 4. So it's 21/4. It wants our answer as a mixed number in simplest form. Well, 21/4 is already simplified, and so now we need to change it to a mixed number. 4 goes into 21 5 times with 1 left over, so it's 5 and 1/4 is our mixed number. Moving on to number 14, we have simultaneous equations. You must show all your workings. So we have a 5x plus 8y equals 4 and a half x plus 3y equals 7. So in this case, there are no coefficients of 1, so I wouldn't recommend substitution method. I would recommend the elimination method. But in order to do the elimination method, we need to have one of our coefficients be the same of either the x or the y. So I chose the x. So multiplied by 10 will give us a 5x plus 30y equals 70 for this bottom equation. The top equation I just left alone. So 5x plus 8y equals 4 is on top. On the bottom, after you multiply by 10, you get 5x plus 30y equals 70. We're going to subtract those so that our x's cancel out. And I'm going to notice this arrow up over here. I like to keep positive values if I can. So I'm going to subtract going upwards. Okay, so yeah, I could rewrite it so that the bigger value is on top, but I just subtracting going up. So 5 minus 5 is 0, 30 minus 8 is 22, and 70 minus 4 is 66. So I'm just subtracting going upwards. That way I don't end up with the negatives. Divide by 22, y equals 3. So plug that into one of the equations. I chose the top one, 5x plus 8 times the 3. So here's the 3 plugged in for the y, equals 4. 5x plus 24 equals 4. Subtract 24. 5x equals a negative 20. Divide by 5. X equals negative 4. So our answers are negative 4 and 3. Moving on to number 15, Shona buys a chair in a sale for $435.60. This is a reduction of 12% on the original price. Calculate the original price of the chair. Whenever you see a reduction or an increase by a percentage, you need to remember that that comes from the original, and the original represents 100%. In other words, the original value is 100%. So anytime you have a reduction, you're going to subtract from 100, or if you have an increase by a percentage, you add it to 100. So since this is reduction, we're taking 100%, that's the original, we're reducing it by 12%. So 100 minus 12 is 88. So now we have 88% of the original price. I was just going to put O for original price, but it looks like a 0. So I put O subscript P for original price equals $435.60. This is what you got on sale for. So to find the original price, we divide by 0.88, and that gives us an original price of $495. Okay. Now moving on to 16, here we have linear inequalities. Linear inequalities, and there's a very important notice here. Notice Cambridge puts this unwanted in bold. Now, why do they do that? Well, some curriculum, when they teach linear inequalities, they have you shade the wanted region. In other words, they have you shade the answer set to that linear inequality. In the Cambridge question, they want you to shade the unwanted part, or the part that is not the answer set. So when you're done with your shading, the answer set is the white or clear section. Everything else has been shaded in. So kind of depends on what curriculum you learn from, but make sure in this you shade the unwanted region. So let's work through this. Here they've already drawn for you the 3 lines. Sometimes they have you draw the lines from the equation. Sometimes they give you the lines and you have to come up with the equations. In this case, they give you both. You just have to figure out which one is which. So let's start with this first one here. y less than or equal to a negative 1/2 x plus 6. This is a y equals mx plus c format. So that means it's going to cross the y-axis at 6. That's this one right here. And has a slope of negative 1/2. So you can see if you go down 1 over 2, you get back to the line. So that's this line. The inequality says less than or equal to, which would be below the graph. So the unwanted is above the graph. So we shade all this here. Usually I shade perpendicular to the line. So these lines going up here are perpendicular to my line. So all this is shaded on the top side because that's the unwanted side. Then we have y greater than or equal to 3x minus 4. Again, it's in slope-intercept form. Crosses the y-axis at negative 4. That's this one right here with a slope of 3. So you can count 1, 2, 3 over 1. So you can see it's this line right here. And it says greater than or equal to, which would be the upper side of the line. So the unwanted is the lower side, below the line. So notice I've shaded in a perpendicular direction to the right, which is actually the lower side. You can just put your pointer on the line and go down, that would be lower. And if you go above, that's the upper side. So this is the less than side, which is the unwanted side. All of this over here is shaded. And then we have x plus y greater than or equal to 5. So this one, what you do is you take the 5 divided by the coefficient of 1, and that gives you a 5 on the x-axis. That's right here. And you also take 5 divided by the coefficient of 1 on the y. That's also 5 on the y-axis, which is this one right here. So that's this line going right through here. The inequality says greater than. You're going to read it from the y variable. So y greater than, which would be above the line. So that means the unwanted is below. So here I've shaded perpendicular below the line because we don't want that. So the section that you have remaining that we're going to label R is this little triangle right here, and there's no shading in it. It's completely blank. It's the only blank space left. I know my shading's not super clear in the graph, but this R, this little triangle here, we label R. There's no shading in it. So that's the section that satisfies the inequalities. Then it says find the largest value of x plus y in the region R where x and y are integers. So you have to find the grid marks, where the grids lines cross each other. Those are integer values. So here you have right here at 6, so that would be 0, 6. Your x being 0, your y being 6, that adds up to 6. You also have 0, 5. Well, that only adds up to 5. Here you have 1 and 5. That adds up to 6 also. And here you have 2 and 5. This one is right on the grid mark as well. Integer values. 2 and 5 is 7, and everything else is below that. So 7, the 2 for the x and 5 for the y equaling 7 is your highest value combination of those xy integers that are within the region R. Okay, now moving on to number 17, write as a single fraction in its simplest form, 2x over x plus 3 plus x plus 3 over x minus 5. So again, when you're adding or subtracting fractions, you want to get a common denominator. So on the left fraction, we have an x plus 3 in the denominator. We also need, to make it common, we need a factor of x minus 5. So we're going to do that top and bottom to maintain the equality of our fraction here. And on the right-hand side, we have the x minus 5. And to make it common, we need to multiply into it the x plus 3 factor. And again, we do that both to the numerator and to the denominator. So on this one here, 2x multiplies through this x minus 5, giving us 2x squared minus 10x. And then on the right-hand side, we have x plus 3 times x plus 3 gives us x squared plus 6x plus 9. Since there's an addition sign here, we don't have anything to distribute through it. And in the denominator, we now have our common denominator that has both an x plus 3 and an x minus 5 factor. Now, when you're doing common denominator, most of the time you do not need to multiply out the denominator. You can leave it as fraction or as factors. But in the numerator, you do need to multiply it out and simplify it. So 2x squared plus x squared is 3x squared. A negative 10x plus 6x is a negative 4x. And then the 9 is the constant by itself. And that now is our simplified fraction, single fraction in simplest form. 3x squared minus 4x plus 9 all over x plus 3 times x minus 5. Moving on, number 18, we have a table, shows number of people in different age groups at a cinema. So here we have our groupings, our classes and boundaries here by ages. So the age from 15 to 25, 25 to 30, 30 to 50, 50 to 80. And then here's the number of people, 35, 32, 44, and 12. That's the frequency. So it says that Dexter draws a histogram. We don't have to draw the histogram on this. Dexter draws a histogram. And from this first class boundary, he draws the graph 7 centimeters. What they want us to do is they want us to calculate the height of the remaining bars. Now, normally when you draw a histogram, your height is the frequency density. So let's just see what Dexter did here. He took frequency density as frequency divided by class width. So he took 35, and the class width is 10. 35 divided by 10 is 3.5. But instead of drawing it 3.5, he drew it 7. In other words, he multiplied it by 2. Maybe he didn't want his bars on a histogram being so short, so he doubled the value. And that's what's important in a histogram, is that the areas of your bars, it's not a bar graph, but the area of your sections are proportional. So if he multiplied that first one by 2, then we need to multiply all the rest of them by 2 as well. So remember, frequency density is frequency divided by class width. So 32 divided by 5, 30 minus 25 is 5, that's the width, gives you 6.4. And then multiply it by 2 gives you 12.8 would be the height of that one in his histogram. Then we take 44 divided by 20 because the class width is 20, and we get 2.2 times 2 is 4.4. And then the last one is 12 divided by 30. 12 divided by 30 is 0.4. Again, multiply it by 2. Make sure you're consistent on all of them, and you get 0.8. So here are the 3 heights of the remaining sections of Dexter's histogram. Moving on to number 19, rearrange this formula to make M the subject. Right now, P is the subject. It wants M to be the subject. We see that we have a fraction here. So first thing we're going to do is get rid of that fraction. We're going to multiply the M to the other side. So now we see we have MP equals K plus M. Notice we have 2 terms with M in it. So in order to get M as the subject, we want all the terms that have an M in it to one side of the equation, and all the terms that do not have an M in it on the other side. So we're going to subtract this M over here. So now we have MP minus M. That's all the terms with an M on the left. And then equals K. The K does not have an M in it, so it will be on the right. Then we factor the M out of those terms on the left, and then we divide by that factor to get rid of it. So M equals K over P minus 1. And now M is our subject. Moving down to number 20, we have a quadratic here. Solve the equation 3x squared minus 2x minus 10 equals 0. Show all your working, give your answers correct to 2 decimal places. Well, the fact that they say 2 decimal places kind of implies that you can't factor this. You're going to have to use the quadratic formula. You could also use the method by Po Shin Lee, the, that new method. You could use that if you know how to use that. We're just going to use the quadratic formula because I don't want to confuse you with a different method. So remember, x equals a negative b, the opposite of b. So careful with the signs. The negative of a negative 2 plus or minus square root b squared. So notice I put the negative 2 in parentheses so that when we squared it becomes positive. So b squared minus 4a is the 3, and c is a negative 10. So be careful to put your negative in there as well. All over 2 times a. And again, the a is the 3. So what I do is I start simplifying my radical. Negative 2 squared is 4. A negative 4 times 3 times negative 10 is a positive 120. So this adds up to the square root of 124. So a negative negative 2 is positive 2, plus or minus root 124 all over 2 times 3 is 6. Plug this into your calculator, first with the positive and then with the negative. So for the positive, you get 2.189. For the negative, you get a negative 1.5225. Or actually the subtraction sign here gives you a negative 1.5225. Now it says to 2 decimal places, so we need the number after so we know if we have to round up or not. So with this one, we need to round up to 2.19. With this one, we do not need to round up, we'll round down to a negative 1.52. Moving on to 21, we have a Venn diagram. It says shade not x intersect y. So here's not x on the outside. And where does not x intersect y? Well, it intersects right here. So this is shaded in, not this little part and not out here, but not x intersects y in this right here. So shade that. Then letter B, Venn diagram shows some information about the number of gardeners who grow melons, potatoes, and carrots. So we have 23 gardeners that don't grow any of these. We have some gardeners that grow melons only, or melons and potatoes, or melons and carrots, or all 3 of them. There's 2 that grow all 3 of those. And you see 10 grow potatoes and carrots. So what it wants us to do, a gardener is chosen at random from the gardeners that grow melons. So somewhere from here, and find the probability that this gardener does not grow carrots. Well, both of these are within the carrot circle. So the not carrots would be the 6 and the 3, that makes 9. And the total number of melon growers are 6 plus 3 is 9, plus 2 is 11, plus 5 is 16 total melon growers. So 9 of the 16 do not grow carrots. So 9/16 is that probability. II says find the number of M intersect P union not C. So first let's do M intersect P. M intersect P are these 2 right here, the 6 and the 2. That's the intersection of M and P. Then union, which means we combine that with not C. So not C is all of this out here. So this out here and the 2, which is a part of this intersection. We only need to count the 6 once. So it's also a part of the not C, but the 6 and the 2 are part of the intersection of MP. So both of those with the not C. So the N is how many is that? So we need to add the 23 plus the 12, that's 35, plus the 6, that's 41, plus this 2, that's 43, and plus this 3, that's 46. So there are 46 growers or gardeners that fit this notation here. Okay. Moving on, we have matrices again. And notice I X'd this one. Again, the new syllabus, you do not have to do matrices. But in case you're interested, let's look at it anyway. Calculate A times B. So here's matrix A 2713 times B. And by the way, multiplication with matrices, the order does matter. You need to make sure you put the A matrix first and the B matrix second. So the B is 3401. When you multiply row by column. So 2 times 3 is the 6, and 7 times 0 is 0, so it just comes out to be a 6. When you multiply row 1 times column 2, 2 times 4 is 8, 7 times 1 is 7, 8 and 7 add up to the 15. When you go to the bottom, this row times this column, 1 times 3 is 3, 3 times 0 is 0, so 3 plus 0 is 3. And then the bottom row times the second column, 1 times 4 and 3 times 1, 4 and 3 gives you 7. So you end up with the matrix 6, 15, 3, 7. Then says find the inverse matrix of A. So to find the inverse matrix, first you find the discriminant. So that's the diagonal down multiplying minus the diagonal up. So 2 times 3 is 6 minus the diagonal up. 1 times 7 is 7. 6 minus 7 is a negative 1. You then take 1 over that value. So 1 over a negative 1. You don't have to simplify it, or you could. It's up to you. Usually Cambridge gives you 2 points and they look at 1 point for the outside and 1 for the inside. But if you combined it, if you multiplied the scalar through, that's okay as well. Then with the matrix itself in the inverse, the 2 and the 3, this diagonal going down, they switch positions, so it's now 3, 2, and the other diagonal is negated. You just change the signs. So negative 1 and negative 7. Now, if you wanted to simplify this as a negative 1 and distribute it through, you could. You get negative 3, 7, 1, negative 2, doesn't matter. Now, what is an inverse matrix? Again, if you multiply A times the inverse of A, and you do your row times column, you're going to end up with the identity matrix, which is 1, 0, 0, 1. That's your identity matrix. So the inverse matrix is what undoes the original matrix. And it's helpful if you're doing, if you're using matrices to solve like linear equations. You can use matrices, make a matrix equation, and so you use the inverse matrix to help isolate your variable. But again, it's not required for the 2020 syllabus cycle. Number 23, here we have a vector with a vector question with a diagram here. So ABCD is a parallelogram. That's ABCD, that's this right here is a parallelogram. And AB is the vector Q. AD is the vector P. So notice P is not the entire side, it's only A to D. That's an important thing to note. Then ABM is a straight line and AB is a ratio of 1 to 1 with BM. So since it's a 1-to-1 ratio, it means they're equal value. So since AB is Q, then BM is also Q. And ADN is also a straight line, and AD to DN is a 3 to 2 ratio, a 3 to 2 ratio, meaning the entire length is 5 units. But what's important here is the P is only a part of the length, not the whole length. So that's going to come into play in this first question. Write vector M to N. So here's M. This M is because it calls it a midpoint down here. So I should have put MID right here. Don't want you to confuse you with two M's. This is point M, and this is saying that X is the midpoint of MN. Okay, so from M to N, notice the vector is drawn in direction toward N. From M to N, remember you do end minus start. So M is the start, N is the ending place. So we need to do a N minus a M. End minus start. So from A to N minus from A to M is what Mn will be. So if you want to write it as a general formula first, you would write Mn equals An minus Am. Okay, so the A to N, notice, would be AD plus Dn. A to N is A to D plus D to N. Well, the A to D is easy. It's P. That's this P right here. Now, the top part, you have to look at, is the P a part or is it the whole? It's a part. If the P was a whole, then the Dn would be 2/5, 2 out of 5, because 5 represents the whole. But P is not the whole. It's only a part. So what we want to do here is say this P is broken into 3 parts. Okay, there's a 3 here. So we're going to break 3 into 3 parts. That means each part is 1/3 P. And this is 2 parts. So 2 1/3 would be 2/3. And when we add that together, 1 and 2/3 is 5/3. Another way you could look at it is break your P into 3 parts, 1/3, and the whole length is 5 parts. So 5 times 1/3 is 5/3. So there's 2 different ways you can do it. You can do it as P plus 2/3 P, or you can just do 1/3 P as an individual part and multiply it by 5, which is the total. Get 5/3 P. Then minus the AM. AM is Q plus Q, which is 2Q. So 5/3 P minus 2Q is vector Mn. Letter B, straight line in M cuts the BC at X. So Mn, this line here, cuts this line or intersects this line at the X. And X is the midpoint of this line. And it says that B to X equals KP. Notice P over here is from A to D, which would also be B to C since it's parallel. So B to C is the value P. So B to X is going to be a fraction of P. We got to find out what that K is. Find the value of K. So B to X, here to here, is B to M plus M to X. Notice this is M to X. This M again means X is the midpoint. So B to X equals B to M plus M to X. So in this case, we're adding the vectors because it's head to tail. Head to tail. Okay, so the B to M is right here, Q, that's easy. And then mx is half, since x is the midpoint, it's half of mn. We already figured out mn, and since x is the midpoint, then mx is half of that. So that's nice because we've already figured out mn. So distribute the 1/2, you get 5, 6p minus q. Then put all that together. Here's q minus q cancels out, and that just leaves us with the 5, 6p. Notice bx is a fraction of p, so the 5, 6 is our fraction. K equals 5, 6. Moving on to number 24, we have this rectangular prism, and they call it a cuboid. AB is length 18, B to C is width 7, and CG is a height of 12. Calculate the angle that the diagonal AG makes with the base. So here's the diagonal AG. and find the angle that it makes with the base. So that would be this diagonal of the base. And so we're looking for this little angle right here. So first we need to find the hypotenuse of this base part. So we have 7 and 18, and we want to find the hypotenuse. So 7 squared plus 18 squared equals AC squared. And that's the Pythagorean theorem. When you get to the end, AC equals the square root of 373, which I wrote here. And now we have 12 as the height, root 373 as the base. And this again is a right triangle. We're solving for the angle, so we're going to use Sekolah. This is opposite and adjacent. So we're going to use tangent of theta equals 12 over root 373. Take the inverse tangent of both sides. Our theta equals 31.85. So remember, first of all, you're using trig with angle measurement here. So make sure your calculator is in the angle or degree mode, the degree mode. And also with degrees, you only go to 1 decimal place. So this will be 31.9 degrees as your answer. Okay, here we have a transformation here. So the first one says, describe fully the single transformation that maps triangle A onto B. So A onto B, notice that it rotates. We can see that the shape changes direction. So this is going to be a rotation of 90 degrees clockwise. Okay, so 90 degrees clockwise. And we need to find the center point. So notice rotation, clockwise 90 degrees. We need to find the center. To find the center, what you do is you connect corresponding vertices. So this little pointy part of this triangle with the pointy part of this triangle, and you draw that line and you take the perpendicular bisector. Then if you draw, say, this corner would correspond to this corner down here, and you draw the perpendicular bisector of that one. Where your perpendicular bisectors intersect, that is your center. So it's at 1, 0, center, 1, 0. 3 points, one for each piece of information, one for rotation, one for clockwise 90 degrees, one for the center at 1, 0. The center is the kind of the trickiest one to find on rotations. So hopefully you would get at least 2 of those 3 points, but that is how you find the center. Then A onto C. Notice A onto C, it looks like a rotation of 180, but the size changed. So if the size changed, it's not a rotation. Instead of it's an enlargement, and because it's flipped upside down, that means your corners crisscross. It's a little faint here, but if you connect corresponding corners, this corner up here would go down to this one, and this pointy one here would go up to this one here. And because they crisscross, that means your scale factor is going to be negative. Okay, so this is going to be, first of all, an enlargement. That's the type of transformation. Second of all, we need the scale factor. And the scale factor here, if you look at the base, it's 2. And if you look at the base here, it's 4. So that's going to be a scale factor of a -2. Now it's negative not because you multiply it by a -2, you're actually multiplying it by 2. The negative is what flips it upside down. So it's because these lines crisscross. So a scale factor of -2, and we need the center point, and the center point is going to be at where these lines crisscross or intersect, which is at 0, 2. So enlargement, scale factor -2, and center 0, 2. 0, 2 is where our lines crisscross from corresponding vertex to corresponding vertex. And that's the end of the paper. So that was paper 22 of the May-June 2019. And again, as always, thank you for joining me, and hope to see you again next time.